Do you want to learn more about Mux Fabric Eventstream? That is exactly what this video is all about. Stay tuned. Welcome to the video. My name is Aleksi and on this channel I cover Mux Fabric and Azure related topics. In this video we'll continue our DP-700 exam prep series and the link to the entire playlist can be found in the description. This is the episode 5 in this DP-700 exam prep series, and in this episode we will cover event streams. That is this no/low-code tool for ingesting, transforming and loading real-time data in Fabric. Like in every episode in this series, we will start with the theory section, followed by demo/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now let's get started. First, let's talk about the different components of Eventstream, and here on the screen we can see the Eventstream development canvas that can be used to configure and develop Eventstream. Let's first highlight the actual Eventstream block or node in this development canvas. This block is the Eventstream to which we are able to then connect our other blocks into. On the left-hand side of our Eventstream block, we have our data sources for this event stream. Eventstream actually supports adding multiple data sources for a single event stream, but we will talk more about those shortly. Then on the right-hand side of our Eventstream block, we have some transformations that can be added to this Eventstream flow, but they are really optional, and we could be using Eventstream without doing any transformations for our data. Then lastly, on the far right, we have the destinations for our data. And like with sources, we could actually have multiple different destinations for one event stream, but in this example picture, I just have one. So here we have the core components of event streams. And like I already mentioned, this is a tool meant for real-time data or near real-time data, depending on the definition of real-time data. So with these blocks or nodes in Eventstream, we can tell it where the data is coming from and what kind of transformations need to happen for it and where we want to send it/write it. So in a sense, this is very typical data engineering work, and the only major twist here is that we are dealing with real-time data and not batch type data like we typically do with traditional data pipelines and data engineering workflows. Next, let's talk more about data sources for event streams. There are a few different types of data sources that can be used for event streams. First, we have many different types of external services that are supported by Eventstream. These include many familiar Microsoft Azure services like Event and IoT Hubs and different Azure database change data captures or CDCs. However, also many services outside Microsoft ecosystem are supported as well, and these include some AWS or Google Cloud Platform services that use, for example, Kafka protocol. But we are going to take a closer look at these services in the demo/tutorial part of this episode. Eventstream is also a very handy tool for processing events that are produced by Fabric itself. So Eventstream can capture and process various Fabric and OneLake events. For example, it can capture events from item creations in Fabric workspace, data changes in OneLake, and events associated with Fabric jobs. With this functionality, Eventstream can be used to build alerts based on things happening in Fabric or OneLake, but more about this later. Then we have support for custom endpoints, which then expand the integration possibilities even more, since you can connect your own application or process to Eventstream using one of the supported protocols that are Event Hub, AMQP, or Kafka. In the demo section, we are going to actually use these to connect some custom code to Eventstream. Then lastly, Fabric offers some sample datasets that can be used to try out different features of event streams. Also, keep in mind that one event stream can have multiple different sources, and you can mix and match these different types of sources if you want. Next, let's talk about data transformations that are optional in event streams, but can be very useful in many cases when you want to do some data processing before writing to a destination. Eventstream supports 7 different types of transformations, and those are filter, manage fields, aggregate, join, group by, union, and expand. And I think that for many seasoned data engineers, these transformations are quite obvious what they do, but let's go them through so that everyone is on the same page. Let's start with filter. That is a filtering transformation like the name implies, and it allows filtering events based on the value of a column in the input. Depending on the data type, number or text, the transformation keeps the values that match the selected condition, such as is null or is not null. This transformation is great if you want to filter out some unnecessary data. Then we have manage fields that allows adding, removing, renaming and transforming columns in the data. Manage fields also supports many different types of transformation functions that can be used on column level. This functionality is very similar to SQL select statement, where you can use functions like concat, substring, etc. and then change data types and rename columns. Then we have aggregate that allows aggregating data using aggregation sum, minimum, maximum, or average over a period of time. Also, aggregate allows renaming calculated columns and partitioning aggregations based on other columns in the data. Next, we have join transformation that is very similar to SQL join command and allows combining data from two streams based on matching conditions between them. Then group by allows more complex aggregations using time windows or windowing functions. And these windowing functions we are going to cover in a separate episode since they deserve some special attention. Also, group by allows renaming calculated columns and grouping aggregations based on other columns in the data. Next on our list is union that allows combining two or more inputs with shared columns that have the same name and data type. Also keep in mind that columns that don't match are dropped and not included in the output. And lastly, we have expand function that is very similar to an explode function in Spark, and it allows creating new rows for each value within an array. Next, let's shift our focus to Eventstream data destinations and talk about those. Like with sources, we can have multiple different types of destinations, and we can also add multiple destinations to a single event stream. Firstly, we can of course write the data from Eventstream to Event House. That means basically writing data to a KQL database that is in that Event House. Event House/KQL database is the most native way of storing and exploring event-based data, and thus this is probably the go-to choice as the Eventstream destination for many. Then we are also able to write data to another Fabric data store, Lakehouse. This way we can write data directly to a Delta table in Lakehouse, and we have that data in the same place with other data that is already there and easily combine them. Lakehouse could be a good option as a destination in some cases, but for event-based data it is less optimal than Event House that is especially designed for this type of use cases. We can also chain event streams together by using derived streams as our destination. However, we have to add at least one transformation before using this, since it wouldn't make any point directly stream the data to another event stream. Then, like I mentioned briefly before, we can use event streams to build some alerts and triggers, and here Fabric Activator steps into picture. We are going to cover Activator in more detail in later episode, but with it we can send emails, Teams messages and trigger other Fabric items using event stream data as our source for those. Then lastly, like with our sources, we can use custom endpoint as a destination and stream data to some custom application using one of the supported protocols that are Event Hub, AMQP and Kafka. And now we have covered the basic components of event stream, and we are ready to go to Fabric and talk more about event streams there and try it in action. But before we open Fabric, I would like to know that I spent a ton of my free time creating these videos for you, and that's why I would like to hit that like button and subscribe to the channel for more DP-700 and Fabric content. This doesn't cost you anything, and I would highly appreciate that. Also, if you'd like to support the channel with a cup of coffee, you can do so by clicking the Buy Me a Coffee link that can be found in the description. But now, let's go to Fabric. Now I have my DP-700 workspace open here, and I would like to create a new item to this workspace, and we are going to create an event stream here. And let's create that event stream, and next we would have to name that event stream. Let's add a name for it, and then we can hit create. And this will then start to load up the event stream development canvas here. And now we would have to pick a data source for our event stream. We have these three options: use external source, use sample data, use custom endpoint. I'm just going to click this custom endpoint since that is what we are going to use today. And then I have to name our custom endpoint. And I'm going to name this CE temperature because I'm going to send this simulated temperature data to this event stream. And then we can click add, and this now opens up the actual development canvas for our event stream. But before we start to send data to this event stream, let's talk about event streams a bit more here. And we can click this settings button here because there are some settings here that can be used for event streams. We have these typical Fabric settings like about, endorsement, tags, and then we have these event stream specific settings here, and these are retention and event throughput. The retention is actually a setting that defines the time that event streams keeps the messages that are sent to it. So here we can specify the retention time we want to have those settings retained in the event stream, and we can specify there a date between 1 and 90. So the 90 days is the maximum that event stream can retain the messages. Then we have this event stream throughput setting here that is not loading up for some reason. I don't know if there is some type of bug going on in Fabric, but with this setting you could adjust the throughput that is specified for this event stream. And also remember that more throughput means more capacity consumption. And also with event streams, it is good to keep in mind that event streams consume quite a lot of capacity. So I wouldn't try to use event streams with those lower capacities like F2 or F4. I would opt for something higher than those. Because if you, for example, try to use event stream with F2 capacity, you will run into issues quite fast. You can try that at home and see what I'm talking about. But yeah, this throughput setting doesn't seem to be loading up. I don't know what is the issue here, but yeah, basically there are a few options that can be chosen for the throughput here. But yeah, let's not wait for that and let's move forward. Before we start to configure our custom endpoint source, we can talk a bit more about these different sources. So we have these three options: external sources, sample data, and custom endpoint. Let's first talk about these external sources here. And like you can see, we have quite a many different external services supported here. Mainly these are some Azure services that we can use as a source for our event stream. But we also have some Fabric workspace item events, Fabric job events, and then we have also Fabric one-leg events. And these Fabric events are especially good for building up some alerts or triggering some actions in Fabric based on arriving data or item creations, etc. But that is something that we are going to take a look at later on. Then we can close this external source, and then we have also this sample data. And here we could pick some sample data provided by Microsoft here in Fabric. So we have some bicycles, yellow taxi, and stock market data, and we could use those to try out the event stream features without having some actual data coming from anywhere. And like I already mentioned before, we could actually add multiple different sources to this event stream, but now I'm going to just have this custom endpoint. And next I will connect my custom code to this endpoint. But to be able to do that, you would have to click this publish button or change to the live mode here. And in this live mode, we can see these protocols that are supported for the custom endpoint. We have Event Hub, AMQP, and Kafka. But today we are going to use this Event Hub endpoint and connect to it. And we are going to use this SAS key authentication. And here we can see all the details that we need for it in order us to connect to this endpoint. So basically we have the Event Hub name here, and then we have these secrets that are primary key, secondary key, and then the connection strings for those. Today we are going to use this Event Hub name, and then we are going to use this connection string primary to connect to this custom endpoint using the custom code that I have built. And here in my VS Code, I have that custom Python code that I have built for this demo. And this custom code can be found by clicking the link in the description if you want to follow along with this tutorial. But let's talk a bit more what this custom code does. So basically this custom code sends these kind of messages to our event stream. And this sends these kind of fake temperature readings based on the configuration that we have here. And for example, if we have configured our country to be USA and our city to be New York, they will be added to the data. And then we also add this timestamp when that reading was created. And then we get these fake temperature readings from these sensors that are simulated here. So we have maximum of 3 sensors here, and then we send some temperature data that is between these min and max temperature values that we have there. And then we specify the sleep time, that is basically the time in between messages when we send those to the event stream. But yeah, when we run this, you can see that we get 1, 2, or 3 sensors when we send the data, and it is not all the time 3 sensors. And I will use that to demonstrate few things in Eventstream later on. Also, we get this event ID, that is this strong hash. That is an ID for this kind of one message that was sent to the event stream. But yeah, here is the rest of the code. It's quite simple Python code, and feel free to modify it if you want to try out your own things. But in order us to run this code, we would need to first install this Azure Event Hub using pip. I have provided the pip command here, so you could use that to install Azure Event Hub. And then we are importing these libraries. And now we would configure Event Hub name and Event Hub connection string here. And I will configure them now, and they can be found here. So basically we have the Event Hub name here, and then we have the connection string primary. And keep in mind that these connection strings are secrets, so you don't really want to expose them. And now I have copied those values, and I will save my code, and then I can start running it. So we just execute it with Python, and it will start running and sending data to that custom endpoint that we have defined there. And now it will start running, and we can see the messages that are being sent here. And so we can see that it's now sending data for 3 sensors. Let's see if we get some messages with less than 3 sensors here. Let's see, now it is sending all the time 3 sensors, but there is a possibility now. There we can see that there is 2 sensors. But yeah, now we are getting this data to our event stream. And now we can go there and do some stuff with it. And let's go to this event stream, and then let's go back to that edit mode. And here we could actually already preview the data. Let's see, let's click that test result, and we can see soon that data is coming in. And here we can see that we are getting some data, and we can see that we have different amounts of sensors that are providing that data. And now we would like to do some transformations for our data and write it to a source. So let's add some transformations. First, I would like to use the expand transformation and expand this array to its different rows, so that instead of having this one array here, we would expand these two to their separate rows. But yeah, let's add that expand transformation here, and we need to set up that, and we can do that by clicking this pencil here. And we can just leave that as expand, and then we can select the array we want to expand in our array data. And that's going to be the temperature readings. And here we could set, do we want to create rows for empty or missing arrays? But yeah, in this case, we don't have any missing arrays, so we can just leave it as default, and it doesn't do anything special in our case. Then we can click save, and then we could actually click this refresh button here and see the results. It is actually throwing this error message because we haven't configured like input for this expand, but we should be able to see the data here once it loads up. And here we can see the data, and here we can see that we have these temperature readings from those sensors on their separate rows. For example, these 3 here have the same event ID, but they are now on their separate rows. They used to be on the one row, so we used the expand function to expand on their own rows. But yeah, next let's add manage fields here, since I want to filter out some unnecessary columns from this data. For example, we don't need these technical columns that are added there when we are sending that data. For example, this event processed time, partition ID, and event enqueued time. And I'm going to drop out those using this manage field. So let's configure that. And we can add some fields here by clicking this add fields, and then we can select some fields here. First, I want to pick something from that object that we have there, where our sensor is located. I want the sensor, then I want some temperature, and then I would like to also have the timestamp, event ID, country, and city. And I think those are all the columns that we need for now. And then we can click add. And I also want to do some light data transformation for these columns. For example, I want to change the temperature data type and have that as double, since that is actually this kind of a float value and it is not a string value. So that's probably better that way. And then I want to transform the timestamp from string to date time value. And then for the event ID and city, maybe we can also use the one function for this city and actually have that as uppercase. So we have these different functions available here in the event stream, and we have these string functions, for example, here, and we can use these to do some light data transformation. For example, we can pick this upper function here and select our city there and have that city as upper value. Remember, I wrote that New York there as lowercase. So with this function, we are able to convert that to an uppercase, and we are going to have that as string. And we are going to have that as city. So we are not going to rename any columns, even though we could. And then we can click save, and then we can click refresh and see how does the data look after our manage fields. And here we can see that now we have picked only those columns that we wanted, and we have that New York there as capitalized, like we have the country already there. But yeah, that was due because we did that transformation for it. And next, I would like to calculate the average temperature per event ID, because we have those 1 to 3 temperature readings per event ID, but now I would want to calculate what's their average. And let's do that, and let's add a group by here, and we can use that to calculate that. And we can configure the group by here and then create this kind of an aggregate function. And for this, I want to use average, and then we are going to select the temperature because we want to use the temperature, and we can actually rename our temperature as AVG temperature as lowercase, so we have the same naming conventions for all the columns, and then we can click add. And now we have added this aggregation for this group by, and then we have to configure what we are going to use to group them by. So in this case, we are going to use event ID. And then we are going to specify the time window, and we are going to come back to these time windows in a later episode. But for now, let's select snapshot, because basically with the snapshot, we just use the event ID and group those values with it. These other window functions are a bit more complex, and we will cover them later on. And now let's refresh our data, and we should have average temperature for each event ID here. So once again, we are getting only one row per event ID when we use this group by statement. This is very similar to this kind of a SQL group by here. And there we can see we have event ID, and then we have the average temperatures for those event IDs. And next, I would actually like to use the join transformation and join this group by back to this data that we had there previously, so that we would have average temperatures on these rows, so that we would know what is the average temperature for each row when we have those different temperature readings here. But yeah, we can do that by adding a join transformation here, and here we could drag first our manage fields, and this upper level here is this kind of left side of the join, and this lower level is going to be the right side of the join. If you know how the join logic works, for example, in SQL, so we are usually using the left join here or inner join, but in this case, we're going to use the left join. And here we can see that we have only two options. We have inner join, and then we have left outer join. So this means that we're actually joining this group by data to this manage fields data, because this is the left part of the join and this is the right part of the join. And then we have to select the columns we want to use as the join keys, and then we are going to use event IDs for both, and then we have that left outer join selected, and then we could specify the amount of seconds within the join is happening. But since we are getting those events at the same time there, this doesn't matter in our case. But if we would be getting a stream of events with some random times there, this could play a role in that event stream. But in this case, this doesn't matter since those events are arriving at the same time. But yeah, we can click save, and then we can see how does the data look. And like we saw, we couldn't configure any renaming of columns with the join transformation, and it's going to add some column names here that we can see shortly. And here we can see that the join added some column names, and it added these left prefixes to the columns that came from the left part of the join, and then added these right ones there that came from the right part of the join. And we were not able to pick any columns that we wanted here, so it just by default added all the columns that were coming in. And now I would like to add one more manage fields here and only pick the columns that I want to have in my output. So let's click add fields, and let's click this imported schema. So I want to have the sensor, temperature, country, timestamp, event ID, city, and then I want to have the average temperature there. And then we can click add, and then we can rename these columns so that we don't have that left or right prefix there. So let's do that. And now I have renamed all of them, and then we can click save. And then we can check out how does the data look now. And here we can see the data. So now we have renamed those columns and only picked the columns that we want. And we have that average temperature in every event row here. But yeah, next I would like to configure the destination for this data. And we can click here and add destination. And we have these 4 options here. So we have the Lakehouse, Event House, Activator, and Stream. And we already covered all of these in the theory section. But this time I want to use the event house. And remember that we could of course have multiple destinations for our event streams. And we could actually add some destinations here to some other point as well. So we would do some transformations after we are already sending data to some destination. But yeah, this time I want to use this event house destination. Let's configure our event house destination. First, we have to provide a name for our event house destination. It is going to be that. And then I want to pick the workspace where our destination is going to be. And it's going to be in this workspace where we are right now. And then we are going to pick the event house in this workspace. And then we are going to select the KQL database in that event house where we are going to write that data. Then next we want to create a new table to that KQL database. And now our destination configuration should be correct. And we can click this save button. And then we can click this publish button so that we will publish this event stream and it will actually start ingesting data to that KQL database from this event stream. And let's click that publish so that it will publish it and we will start to ingest that data to that KQL database. And now it will start to load that destination and it will start ingesting that data. And this will take a little moment until we can see that data there, since it is now creating the table and setting everything to be ready there. But yeah, shortly we will have some data in our KQL database. And after a little wait, we can see that now our destination is actually active and we are ingesting data there. So let's go to our event house and let's check out how does the data look there. So let's open up our event house and then let's open up the default KQL database in that event house. And here we can see this temperature table here. And it is actually saying that table is empty, but I think there is actually already some data. I think that is just a bug. And let's click that show 100 records and we can see that there is some data. And now we have managed to ingest the data to this event house's KQL database. And here we could actually start query this data and see what kind of insights we would be able to get from that data. But yeah, since Event House and KQL database are not topic of today's video, we are going to come back to those later on, and now we are not going to start query this data anymore. And next we are going to have some questions about event streams so that you can test your knowledge and see that did you learn everything what I covered in this video. Our first question today is, which of the following event stream transformations allow you to rename columns? Is it A, expand and manage fields, B, filter and manage fields, C, join and manage fields, D, group by and manage fields? Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D, group by and manage fields, since they both allow renaming columns. However, with group by you can do this to a less extent than with manage fields, since it only allows renaming columns that are created by it, but it allows renaming columns. Expand, filter and join don't allow you to rename any columns, so that's why A, B and C are incorrect. Let's have another question. Which statement is true about event streams? A. Event stream supports using custom endpoints as a source, and supported protocols for it are Kafka, AMQP, and IoT Hub. B. Event stream can forward data to another event stream using the derived stream destination if no transformations have been added to the event stream before it. C. Supported event stream data destinations include custom endpoint, lakehouse, warehouse, and activator. D. Event stream data transformations include following transformations: union, group by, manage fields, explode, join, and filter. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is B, since you can't forward data to another event stream using derived stream destination if you don't add any transformations before it. What comes to our incorrect answers, A is incorrect since supported protocols include Kafka, AMQP, and Event Hub, not IoT Hub. C is incorrect because warehouse is not a destination option. And finally, D is incorrect because there is no explode transformation in event stream, but there is expand transformation. And that is all that I wanted to cover today. I hope you learned something new about event streams and now you are more ready to take that DP-700 exam. And if you would like to continue learning more, check out the next video in this series. Now I thank you for watching and see you in that video.